Hey everybody, Jason here. I hope you're all doing really good. Today I am working on an iPhone 8 Plus PCB that will not charge the battery. I have already replaced the TriStar IC, I have replaced the Tigris IC, and I'm at a point in this repair where I need to show you guys something that's really stupid. Here is the bottom end of this board. Now, on the back side of the board, I have already replaced the TriStar IC, and I have already replaced the Tigris IC, which is this one right here. Now, the Tigris IC on this model, I find that it is responsible for the charging issues usually, and on this particular board, this IC was actually visibly burnt and had like a little volcano of like splooge coming out of it. So this board initially would not charge at all, and after replacing the Tigris IC here, I was able to get a USB connect, but it would not draw any charging current. So just operating on autopilot, I went ahead and replaced the TriStar IC here as well, and that didn't make one bit of difference. The symptoms were still exactly the same. I can get a USB connect, but it's literally drawing 50 milliamps of charging current through the charge port. So here comes the really stupid part. On every iPhone, we have these little switching power supplies scattered about. These switching power supplies, they rely on a coil, and they basically spank the voltage through a diode and into a capacitor bank. So without the inductor in that circuit, it's not really doing any spanking. So on every single iPhone, we have got these switching power supplies quite literally all over the place, and Apple has taken common failure power supplies and just went ahead and smooshed their coils into this package here. Now, on the iPhone 7, that little package of coils, they called it Trinity, and on the iPhone 7, it was just that, it was just a pack of coils. And that was annoying enough because backlight shorts are really common. You get a short in one of these output capacitors, and that puts the load through that coil, and those coils just boil. And that's actually a common failure point. So I know, I'm getting to it. So on the iPhone 8, this is no longer called Trinity. It is called Lisa. And Lisa, at first glance, would also appear to be like a conglomerate of coil packs. You know, here's your Tigris LX line coming in. We've got VDD main coming in. So here we can see, you know, VDD main's coming in here and it's going through to Tigris, but they're also splitting that out. And, you know, here is one of our backlight coils. Here's also another, you know, backlight coils. We've got more VDD main here. So, I mean, this thing, it appears just to be a coil pack. So to the unsuspecting soul, let's just say the unsuspecting soul comes in, you know, they got a customer that just has a little backlight problem or just has a little charging problem, and you dig in and you just go ahead and you know the coils inside this little chip are smoked, so you just go ahead and replace it. So just have a look a little bit closer. Let's just get a little bit closer, folks. Look what we have here. Lisa has an I2C line going to it. We have us a clock line here, fellers. It also has a data line, and we've got PP1V8 IO going to it. This little pack of coils that any one of them can get smoked just by a simple shorted output cap also contains the logic EEPROM data. It's embedded into Lisa. And what that means is me as a board repair tech, if I don't know this and I come along and try to fix like half backlight caused by a blown coil, when I swap that out, this phone would no longer boot, and the only way to get it to boot again would be to completely erase and restore all the data. It's absolutely ridiculous. On the iPhone 6 models, it's a little glass IC that's hiding just up under the shield right here. On the iPhone 7, it's a little glass chip right next to the boost IC. On the iPhone 10, it's a tiny little chip right next to the Hydra IC. On the iPhone 10s and 10s Max, it's a tiny little chip right next to the CPU. All of these other models, and I could just go on and on and on, but all of these other models, that logic EEPROM is somewhere freaking else. So to get the data out of this pack of coils, we need to be able to hook onto I2C for AP_SCL, and we also need to be able to get on I2C for APSDA. But this thing also needs powered. It's going to need 1.8 volts plus ground. Now, if we look at these I2C lines, look at where they go. I mean, this is pretty freaking secure. The only place on this model to get on those lines is actually under the CPU or under this chip. Now, that's not true on all models, but it is on this one. So here's how I know for absolute certain that Lisa is bad. If you look very closely, you can see just down toward the bottom of this package, there is a crack. It looks like maybe it's separating or something. And then if you look very closely, and I mean very closely, you can see that we actually have balls oozing out of Lisa that are not supposed to be here. So since the only place we can access those data lines is either under the CPU or beneath Lisa, I'm going to choose to remove Lisa and do it that way. Oh, look. We've actually got some lead-free spatter out here. This is actually in the form of like that stringy, you know, usually whenever you heat underfilled components, you get ball squeezage. But there are some situations where you can actually get this stringy, hairy, like it'll make a long hair structure. That was sort of it. All right, so I'm just going to begin warming this up and get Lisa off this board. Now, so I've got a much better idea as to when exactly this is going to melt. I am going to go ahead and get just a little flux in there. And I'm using that basically as a reference. And judging by it boiling just now, I'm getting really close. All right, let's see if I can get a tool under this to feel when it starts to give. That ought to do it. Come on, baby. Okay, I'm going up to a hot air temperature of 430 degrees C now. Airflow of 4T. I was at 340, which I decided just now was just not going to do it. So any minute this thing should start to give. And I'm going to abandon the flip and pry method, and I'm going to go back to the lift method here. Any minute this should let go. Oops, there it goes. Well then, ladies and gentlemen, the first thing we'll do is fix everything that I just screwed up, which thankfully is just these two itsy bitsy, just these two tiny itsy bitsy little caps here that they don't matter. So I want everybody watching this at home right now to pretend like that didn't happen. Okay, here goes one. Here comes two. Yes. All right, now while this board is really stinking hot, I'm going to go ahead and shine up this whole entire area and ready this to receive a brand spanking new Trinity, Lisa IC. So I'm just going to get a little bit of flux in here like that. And I'm going to try this with my micro pencil first. Come on, beep. There it is. Oh. Now I'm reducing my hot air back down to 340 because I'm trying to switch away from lead-free. And I'm just taking my tip here blobbed with 6337 leaded solder, and I'm shining up all these pads. We need everything here to connect, fellers. Not only do we need this board to charge, but we need to have two working backlight circuits.
And we need it to boot, imagine that. Starting to run a little dry here. Let's get some more flux on this spot and on that spot.
All right, that's all looking pretty good. I'm going to leave it exactly like it is. So I've got the damaged thing off of the phone here, And this is its actual size. So there's the size of the pins on the bottom. It is actually rather small. Now, to get the data off of this, I'm going to be using the Qianli iCopy S 4-in-1 double-sided chip test stand. This is not a paid promotion. So the iCopy S, as you can see, it does not have anywhere to plug this thing. The way this device normally works is you remove the CPU, and then this thing has pins sticking up here in just the exact right spots so that it makes contact when that board is laid on there. Which, by the way, has been tricky for boards that are broken and don't have this extra peg up here. So with that held on there, we can actually connect it. And there it's now, it's now connected to my computer, and it's indicating here that we are getting a reading. So looking at the software that's used on this thing, it shows device connected here. We can actually click on load chip. So then without unsoldering the chip that actually has that logic data, I've actually been able to just import that into this application. And then from there, you can click on Save File, and that allows you to save a backup copy of that logic data outside of this chip. So since we don't have anywhere to plug this little chippy here, we're going to look elsewhere on this device. And if I remember right, there was a spot cut out. Oh, yes. What do we have here, fellers? This little gizmo has some other stuff we can use here. Look here. We've got iPhone 8 Plus, data line, clock line, ground. We have data line, clock line, and then 1V8. We can see that this data line, clock line is for 7 Plus. This data line, clock line is for 8 Plus. That does make me wonder what the difference is in the data. Like, can I just hook this to any logic EEPROM IC? So what I have to do is I have to figure out a way to connect this to that. So having a look at full export view, which I'm thankful has data available for the iPhone 8 Plus, here we are looking at this thingy, and we need to figure out exactly what is what. So to transfer this data, we need some of these pins that are right here in the middle, right? We need PP1V8IO, which if we count from the side, we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then to make things really complicated, we have to remember that this chip is, it's flipped upside down. So I'm going to be... All right, so I've got this turned to where it lines up on the screen with the board view. Now, to do this, as you can imagine, I'm going to have to run some really, really, really tiny wires. I need to say thank you to somebody. Christos from Greece, you sent me these iNeasy tweezers ages ago, but since I'm weird, I've been leaving these packaged up and waiting for the opportunity to thank you. And thank you. I really appreciate this. Okay, so 14 pins over and 1 in is our 1V8 IO line. Now remembering that this chip is flipped inverted, we're going to go 14 this way. So PP1V8 IO is going to get soldered right there. All right, so we'll bring that wire. I should have actually stuck this chip down. That was silly on my part. Anyways, I'm going to bring this wire right on down. And we're going to solder that to 1V8, which is over here on the right side. There we go. So the other end of that wire is going to go right there. Tiny little bit of flux because I don't want to funk up my nice tool. I really like this tool. And we're just going to stick that down right here. Okay, there we go. We have 1V8 soldered on. Now, we have a point of reference on the bottom of Lisa, and I no longer have to count like a kindergartner. So then, having a look at Lisa, we know that this line is 1V8 IO. If we go 1 pin farther toward the center, that's going to be our data line, our SDA line. So I'm just going to go ahead and snag on that one next. That one is going to get soldered right here. Oh, come on. Good enough. We're going to leave it just like it is. And then this one, we're going to go over here to our 8 Plus side. And we got to go all the way over here to the far side. This one is going to be our SDA. So we read that from the right, we're ground SCL SDA. So let's go ahead and get our data line tacked on. Very nice, sort of. Now then, looking back at the board view, we can go for our clock line, which that one will not be inverted. That is still going to be one little notch to our right from the first one that we tacked on. The clock line is going to go right there. And we'll drag this right on over. And we're going to be connecting that one right there. There we go. So that has our 1V8 IO for power. We got our data line, our clock line. Now we just need ground, which is pretty sneaking easy because it says here that we can grab this connection on any of these outer pins, and about every other one or so has 2 of them that are ground. So I'm just going to solder this right across these 2. There we go. And then the other end of that, quite simply, just hooks to ground. We'll get us a good blob of solder on here. Ah, yes. All right, so here we go. I got this all wired together like a madman, and I'm going to go ahead and connect the power, and hopefully we get a beep beep instead of an error. Any minute. Come on, baby. No chip detected. Please connect chip and then retry. Well, that's pretty self-explanatory. So now I'm just sitting here staring and just double checking and try to figure out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Why do I always do it wrong whenever I'm making a video? Everything here is a full column off. I did it all wrong. Every single thing is soldered to the wrong pins. So, you know, hopefully I didn't destroy anything. So what I have to do here now is just grab everything and move it over to the right. Good enough. Definitely not going for pretty at this point, fellers. I don't care if it's hanging by a twig. There we go, and they're pretty much all hanging by twigs, so let's see if that works. All right, here we go. Drum roll, please. I've now soldered those on the proper pins, and let's hope we get something. Oh yeah, baby. We got a green light and a 001. And now I'm actually able to click on the software, load chip. Data loaded successfully. That was a little fast. Let's just... So it says loaded successfully, but the data is just all zeros. Okay, so this is actually thoroughly embarrassing. I'm pretty sure what I've done here is I've actually accidentally soldered this clock line right here to ground. So this thing connects, you know, it powers up. We've got a data line, but this clock line, I'm pretty sure I'm 3 in instead of 2 in. So back under the microscope, and sure enough, we can see quite clearly here that I have soldered the clock line directly to ground. This would not be an STS video without me soldering something directly to ground. So then, let's just go ahead and let's just solder our little clock line right there, shall we? And then once more, let's connect our power. We get the same number, a 001. And now on our software, we're going to click load chip. Data loaded successfully. It happened instantly. So just looking back over this one more time, I'm going to trace these down and make sure I do have them hooked to the right spot. This one here should be our clock line, the one I just moved. It is. And then the next one over here, that should be our data line. it is. So then I have to wonder, could they have it labeled wrong? You know, it couldn't possibly be me that just accidentally torched all this data. They had to have labeled it wrong. So let's just go ahead and let's just move this over to the 7+ side of things. Grab our clock line. Oh, we should turn it off first. That would be smooth. Okay, and then let's move our data line. And I've basically got it hooked onto the iPhone 7 side of things. Still says there's a chip detected, but whenever I click load chip, it does it immediately. It should load data here. And I think maybe what happened is that me having that clock line hooked up wrong has actually corrupted this EEPROM. So let me just try a test file. I've just opened a file that I saved that has valid logic data in there. So then now if I go ahead and click this auto recording button, which is going to write that data to this EEPROM, let's see what happens. It shouldn't happen immediately. See, it actually takes some time as it is sitting here and writing data. This is not something that just happens like that in a flash. And we got data transmitted right in success. And then just to test this and show you what I'm talking about, if we click load chip, so with the test data set loaded onto this chip, I'm actually not able to turn right back around and read it. It just flickers and says it loaded. So I think I'm dealing with some sort of an equipment glitch here. You know, if I'm able to write this chip, I should be able to read it. Well then, lucky for me, this is not an actual device that has irreplaceable data on it. The folks that sent it here, they tried to do a factory reset to solve the charging issues. So it is a fresh restore. I think there's a chance here that, you know, I either toasted the data by hooking up the clock line to ground or something, but there's also a chance that I caused damage with heat. And I can say with undoubtable certainty that the data that's on this chip now is no longer there because I just overwrote it, and it's also trash. So this donor board here, although moderately abused, I believe does have a good EEPROM IC on it here. So I'm going to go ahead and pull this from the board. I'm trying to get most of my heat below it instead of heating through this crazy coil thing. I'm actually trying to heat underneath it mostly, but you know, that just doesn't work. There we go. Oh yeah, this is actually coming off a board that I swapped, and it's pretty clear now. I mean, they had floated stuff all over the place. All right, so let's get us some brand spanking new balls on this thing. I'm gonna switch over to reballing station B here. So first, I'm gonna need to get rid of all this lead-free garbage that they have on here. So I'm just going to take me a nice blob of 6337 leaded solderer and start sort of hovering this around and sucking up some of this carnage. Being very careful not to damage it. Right, we're starting to look pretty good here. Now, I'm not going to be extraordinarily picky, not anything unusual anyways. Now I'm going to clean this up with some alcohol. And as soon as the pads are nice and clean, nice and dry, we can put some nice shiny new balls on them. Alrighty then. Alright, now I'm just going to take some of this hard and crusty solder paste and force it down into the holes. Boy, without the microscope, it actually looks like some nasty, dry, crusty paste. But it's still got some flux in it. It'll work. So we're just going to smoosh this all down into the holes, right like that. There we are. All right, here we go. I have got my hot air set on 295 degrees C with an airflow of 40, and I'm just going to carefully begin warming this up. I'm going to try to float its balls from the left to the right, so let's just keep a close eye on this. Now these stencils, they like to warp. So we got to try to heat them up as evenly as possible and use as little heat as possible. So here we go then. I'm going to start floating this from the left side to the right. And although this paste did seem somewhat wettish, this flux is just not doing me good things at all. So I'm going to slowly let this cool off and add a little bit of my own flux, because this isn't flowing worth a turd here. Now, let's go ahead and heat this right on back up. All right, here we go. Now we'll make us some nice shiny new balls. Oh yeah, baby. There we go. A little bit wet, honestly. All right, so now I have a brand spanking new Lisa IC with new balls on it. And I'm just going to go ahead and sit that right down on the board there where it goes, or, you know, hopefully where it goes. So I'm just going to start warming the whole area up and see if I can get this to settle onto the board. It should go right in there, right about like that. Come on, baby. Any minute, this thing is going to settle down into place. Hopefully, right into place, and it doesn't like move a huge amount because I've got it sitting there wrong. There it goes. All right. So that's got Lisa back on the board, but I'm really sad to say this thing's not, it's not going to boot. It's going to need software restored, and had this been an actual data mission, I would have just failed. So let's just slip this right on into a housing. Can you tell this one has been having charging trouble? Now, the very first thing I am anxious to see is whether or not it will pull charging current, because before it would not. All right, so now I'm going to connect a charger and see if we get proper charging current. I'm going to plug in a battery that I know has good battery data pumping out. I know, it's an iPhone 10 battery, but it'll be okay. All right, so now I'm going to connect a charger, and we are actually still not drawing any charging current. Doesn't that really suck? Well, all right then. I know that I have replaced 2 components that were for sure bad. Why am I sitting here messing with Logic EEPROM to troubleshoot a charging problem? Like, seriously? I'm not an engineer, obviously, but I just cannot figure for the life of me why we would take such a crucial piece of information and hide it inside of a pack of inductors. Like, I don't understand. If you know more about this than I do, please let me know in the comments below. I'm going to have to move on for now. So anyways, I do hope that you all enjoyed watching me suffer and fail to fix this phone. And I will see you all really soon. Have a good day. Thanks for watching.